Hello dear viewers, welcome to yet another video on non-destructive testing methods. In this video, we will discuss about radiography testing. Radiography testing is one of the most important, versatile and widely accepted of all non-destructive examination methods. In radiography testing, X-ray or gamma ray is used to determine the internal soundness of the metal, and hence it is also called as X-ray or gamma ray testing. The principle involved in radiography is difference in density. The metal surrounding the defect is denser and hence shows up on lighter than the flaws on a X-ray film. The principle of radiography is similar to the way bones and teeth show up lighter than the rest of the body in X-ray films. Radiography inspection employs the same principle and equipment as those of medical X-rays. Radiography testing is a method of inspecting materials for hidden flaws, defects, by using the ability of short-wave electromagnetic radiation to penetrate various materials. The density of the radiation that penetrates and passes through the material is captured by radiation sensitive film. In radiography testing, the part to be inspected is placed between the radiation source and the radiation sensitive film as shown. The part of the inspection will stop some of the radiation where thicker and more dense areas. The radiation that passes through the defective area causes more exposure on the radiation sensitive film, resulted in different exposure and are shown in the form of shadow graph on the developed film. The film darkness will vary with the amount of radiation reaching the film through the test object, where darker area indicate more exposure and lighter area indicate less exposure. This variation in the image darkness would be used to reveal the presence of any flaw or discontinuity inside the material. The advantages of radiography testing include minimum surface preparation. Both surface and subsurface defects can be identified. It is sensitive to change in thickness, corrosion, voids, and cracks. It provides permanent record of inspection. Wide variety of materials can be inspected. It can be used to inspect complex shapes and multi-layered structures without deassembly. The limitations of radiography testing include: it is the most costly NDT method since it involves expensive equipment, film, and processing. Access to both sides of the specimen is required. It cannot detect planar defects readily. Orientation of the specimen is critical to ensure the defect. If the orientation is not proper, the crack may not or flaw may not be properly identified using this method. A determination of flaw depth is impossible without additional angled exposure. Extensive operator training and skill is required. Additional safety measures are essential to prevent radiation hazards for personnel. With this, we come to the end of this video. Thank you very much for patiently listening. See you in yet another video. Until then, bye.